Hello again. This would be the part 4 of our one about chain rule involving trigonometric functions and inverse trigonometric functions for this part. Okay, so at the end of this video, the students should be able to identify and discuss the rules for trigonometric functions and inverse trigonometric functions and find the derivatives of trigonometric and inverse trigonometric functions in the problem. Okay, so first let's have again the problems here are lifted from the module of Philippine Science High School. All right, in reference or for for the purpose of additional reference of the students in their studies. Okay, or in studying Math 5, the differential calculus. Okay, so in the given example, or examples on the left, we have the trigonometric functions, a simple trigonometric functions that need to be differentiated, wherein there's no need to use chain rule here. While on the right, these are the trigonometric functions and inverse trigonometric functions that need to apply chain rule. But then again, as I mentioned earlier, or in other parts of the video, even a simple functions need to have chain rule, but we don't show it anymore because the okay the there's no need to show because the derivative of the variable maybe could just be equal to 1. All right, so in this case, let's go on to the problems, okay, or to the rules. Let's have a recap on the derivatives of the trigonometric functions, okay, with or without using the chain rule. So these are the original trigonometric derivatives of the trigonometric functions from sine, cosine, tangent, cotangent, secant until cosecant. Now, in this case, let's deal with the derivative of sine x. In the derivative of sine x, it shows here that it's cosine x, all right? Actually, that is true and that is correct, but originally, there is an x here, so times the derivative of the variable x, okay, or x prime. Since x prime is just equal to 1, or the derivative of x is just equal to 1, so therefore we don't write it anymore. And as well as x here, x prime times x prime. Okay, so there must be parentheses here, parentheses, parentheses, x prime, parentheses, x prime, and x prime. So all of these x prime expressions are equivalent or equal to 1, and we don't need to write it anymore in this expressions or trigonometric, the derivative of the trigonometric functions because they're just equal to 1. However, uh, technically, we're still doing the chain rule here. It's just like we're doing it as simple as we could here, right? Unlike on the functions that we can see on the right, now instead of using x, we use u in terms of x. So u is a function of x here. So we have du over dx is just similar to the x prime here, okay? So if you have if the function given or the variable here is not just an x, but a function in terms of x, now we will be differentiating the value or the expression that we have here in x. So same as doing as this, okay? Or you can use u prime instead of du over dx, all right? So again, the derivatives of the trigonometric functions, sine, cosine, negative sine, tangent, secant square, cotangent, negative cosecant square, secant x, tan x, cosecant is negative cosecant times cotangent x. So as you can see, all of those trigonometric functions that start with c have a negative derivatives. Okay, so that's what that is one of our uh, patterns. Okay, so let's deal with example number 1. So the given here is y is equal to tangent. Let's say y is equal to tangent. Let's just remember our formula here. Y is equal to tangent is equal to secant square x times x prime, right? Just to make it simpler. Okay, so let me change the color of my pen to white. So this becomes f of x is equal to tangent 4x squared minus 3x plus 1. Okay, so the derivative of f of x is equal to, what's the derivative of tangent? That's secant squared. And of course, we just need to copy that given angle measure, which is expressed in terms of 4x squared minus 3x plus 1. All right? And here, we're not yet done because we still need to differentiate the x or the angle measure here, just like what we have given in our review. So this is the derivative of 4x squared minus 3x plus 1. Derivative. Don't forget that, okay? And again, that's all right, separate from the angle measure for x squared minus 3x plus 1 here. So we have copy secant square or x squared minus 3x plus 1. And we're now ready to differentiate the function. So this is 8x minus 3 plus 0. So this becomes, let's put this expression as a coefficient of secant square. So 8x minus 3 times secant square 4x squared minus 3x plus 1. So this is our f prime of x equal to. Understood, guys? So by the way, at this step, now you could directly differentiate this, okay? To make your solution shorter, all right? Okay, I hope everything is okay. So let's do it directly. Method 1, although they're just the same, but I just wanna show how it's being done such that everyone could apply this technique. So tangent 4x, let me check, 4x squared minus 3x plus 1. So the derivative of f of x is equal to, the derivative of tangent is secant square, copy, square minus 3x plus 1. And what's the derivative of this? We need to differentiate this. We have 8x, 3. And of course, this is 0. So we have 8x minus 3 secant square 4x square minus 3x plus 1. Okay, so it's just actually the same. I just made it simpler or shorter. All right, so let's work on number number 2. So y is equal to cosine 4 7x squared plus 1. And let's just recap that y is equal to cosine x. The derivative is y is equal to negative sine x times x prime, right? Okay, so here, however, in this case, cosine has a power of 4, or has an exponent of 4. Therefore, we're going to use chain rule and power rule, all right? Or chain rule, in short. So how do we do the power or the chain rule? We have, or let's use the letting first. So as we can do it systematically. So method 1, we let u is equal to cosine 7x squared plus 1. Okay, so therefore we have y is equal to u raised to 4, correct? So here, now we can now, since we're looking for the derivative of y, so we have y prime is equal to 4u cubed times u prime, correct? And we can differentiate u. So u prime is equal to, what's the derivative of cosine? That's negative sine, copy, 7x squared plus 1. And since this is still another function, so we need to differentiate this. This becomes 14x, correct? So again, differentiate this, okay? So we have 4, what is our u? U is cosine 7x squared plus 1, okay, cube, this is cube. times u prime, which is negative sine 7x squared plus 1 times 14x. So how do we write the final answer? Oh, sorry. So for the final answer, so let's simplify. I'll just write down here the final answer. So y prime is equal to, let's simplify, 4 and 14x. And we have negative here. So this becomes negative 56x and sine 7x squared plus 1 times cosine cube, right, cube, 7x squared plus 1. So this is our final answer. Okay, and let's do method 2. Method 2 is more of direct approach. Okay, and I love direct approach because it lessens my steps in finding the solution, and it lessens also the error that I'm going to encounter because I will not rewrite and write a lot of things. Okay, so y is equal to cosine 4 7x squared plus 1, if I'm not mistaken. Yeah, okay. So let's differentiate this. Y prime is equal to, since we have a power, so we need to use the power rule. So 4 cosine cube 7x squared plus 1, right? And of course, since we differentiated this using power rule, we need to differentiate cosine 7x squared plus 1 prime. Okay, so copy 4 cosine 7x squared plus 1. This is cube, of course. And let's differentiate this. This is prime, okay? Prime. Okay, what's the derivative of this? The derivative of cosine is negative sine. Of course, we just need to copy because the function, trigonometric function sine cannot stand alone without the angle measure. And since we are differentiating a function or a composite function, of course, we need to differentiate the 7x squared plus 1 as well. So that's 14x. There we go. So let's simplify the expression. 14, negative, and 4, so 56, negative sine 7x squared plus 1 times cosine cube 7x squared plus 1. Here we go. So this is our final answer. Or you can write this in this form, negative 56 then cosine cube 7x squared plus 1 times sine x squared plus 1. It doesn't really matter as long as you properly or you have properly written the sequence of the factors correctly. Okay, so let's check. There we go. So we got it correctly. All right, so let's move on to the next. Here we go. In example number 3, it is the application of derivatives. So a particle moves along a coordinate x-axis. Let me use another color. Along a coordinate axis, its position at time t is given by the formula. What is the velocity of the particle at time t equals pi over 6? Okay. All right, so what is the velocity of the particle at time 6? So which means, guys, we're going to differentiate this function as t. Okay, so let me just copy 2t. Better if there's parentheses plus cosine 3t. Let me just change the color of my pen to white. Okay, and to find the velocity of the particle, so velocity of the particle at pi over 6, we need to get the derivative of st, okay? Where t is equal to pi over 6. All right, so it's just like finding the slope, all right? So let's now differentiate. We have s prime of t is equal to, what's the derivative of sine? The derivative of sine is cosine, copy, and the derivative, okay, let's just copy this and let's not differentiate it right away. So plus cosine is negative sine 3t times 3t prime, okay? So prime and prime. So let's differentiate. We have the derivative of 2t is 2 cosine 2t minus, this is the derivative of 3t is 3. So negative 3 sine 3t, which is s prime of t. All right, so this is now the velocity in general form. Okay, however, we need to identify the velocity of the particle at time t, which is equal to pi over 6. So this becomes s prime of pi over 6 is equal to 2 cosine 2 pi over 6 minus 3 sine 3 pi over 6. So this becomes 2 cosine pi over 3 minus 3, of course, parentheses. So it will not be getting errors or misconceptions about the way we wrote expressions. Sine, this becomes pi over 2. Okay, here we go. So let's move on to the next slide. Prime of pi over 6 is equal to, oops, that's cosine pi over 3, 2 cosine pi over 3 minus 3 sine pi over 2, or 3 sine pi over 2. Here we go. So what is cosine pi over 3? Again, we're going to use the unit circle. So pi over 3 is here. Pi over 3 is just equivalent to what? To 60 degrees, right? So if this is 2, this is 1, this is square root of 3. So therefore, cosine pi over 3 is opposite over hypotenuse. Square root of 3 is equal to square root of 3 over 2. So I hope you can already solve for this without using this Sokat or Joshua. All right, we can even do that directly. So square root of 3 over 2 minus 3. And what is sine pi over 2? Pi over 2 is somewhere here. That's 90 degrees. And this is 0, 1. Sine is just equal to y. So therefore, this is just equal to 1. So this is something like this. And square root of 3 minus 3. All right. So pi over 6. So therefore, the velocity of the particle at time pi over 6 is equal to square root of 3 minus 3. Okay, this is the velocity of the particle at time pi over 6, which means this is less than 0, right? So which means what? Decreasing its velocity, okay, per time, over time. All right. Okay, so did we answer the question number 3? What is the velocity of the particle at time? Yeah, we did. Okay, so the answer is this. Here we go, this one. All right, next. Oh, here we go. So let's move on to the derivatives of the trigonometric and inverse trigonometric functions. Now we have already discussed how we arrive at the derivatives of the inverse trigonometric functions. Okay, we even derive them, and I hope you remember everything. However, don't worry, because there are specific patterns, or there are patterns that we can use to remember their derivatives respectively properly and easily. Okay, look at this. Sine and cosine have the same. However, the one for sine and negative for cosine. All right. Tangent and cotangent have the same format. However, when tan is 1, the cotangent is negative 1. So the denominator is just equal. For secant and cosecant, the numerators are the same, but this one is negative, this one is positive. Okay. and the denominator is x over x times the square root of x squared minus 1. So they're just the same. And look at this. The c are the ones with the negative values on the numerator. Okay, here we go. This one, the the cosine, the cotangent, and the cosecant are the negatives. Okay, the negative derivatives. Okay, so we have actually this one does not need a chain rule, but again, as I always tell you from part 1 to part 3 of the videos I made, now this can also be or chain rule can also be applied here. However, it's just x prime x. X prime is just equal to 1, right? However, this will guide you, or this will guide you on how to do the chain rule in the a more complex trigonometric, inverse trigonometric functions. Okay, so x prime, x prime, x prime. Again, the reason why they are not placed this anymore because they're just equal to 1. However, this will guide us on how to do the chain rule with the with this kind of formula. All right, so the du and the du over dx is just equal to x prime. Okay, or similar to x prime. However, the u here is complex than the x here. So u is a function of x, all right? While here is just an x. But just consider this as a function, another function in terms of x. So as you can relate the simple formulas to a complicated one, okay? Wherein it needs to undergo chain rule and power rule for us to successfully differentiate the inverse trigonometric functions. All right, so I hope it helps. Okay, so cosine, we're differentiating inverse of cosine. Again, if y is equal to cosine, inverse of cosine x, again, the derivative of this is equal to -1 since it's co. Okay, and this is 1, the square root of 1 minus x squared, if I'm not mistaken. So let's check. There we go, 1 minus x squared, correct. All right, so the problem, let me just copy the problem. F of x is equal to cosine minus 5x. Okay, let me change the color to white. Okay, here we go. So let's start differentiating example number 4. So the derivative of f of x is equal to, since it's cosine, we're going to use this formula. 1 over, this is negative, 1 minus, since x here is 5, so that's 5 squared times the derivative of 5x. Okay, so this becomes -1 over 1 minus 25x squared times 5, which is equivalent to -5 over 1 minus 25x squared. So this is not the derivative, okay? Again, once we memorize, guys, the formula, the basic formula here, then it will just be easier for us to determine the formula with the use of chain rule by differentiating the x after getting the formulas here. All right, I hope it helps again. Okay, so I hope we got the correct answer. So, okay, so before we go to the next example, is there a way to easily memorize or familiarize with the derivatives of the inverse trigonometric functions? Actually, yes. Okay, what you can do is this: sine, all right, sine, cosine, inverse x, and then here is tangent x, cotangent x. Here is secant inverse x, and here is cosecant inverse x. So this is equivalent to, this is the derivative, okay? The derivative is equal to, let's say this is something like that, d, okay, d, and d in terms of x, of course. So this is equal to 1 over the square root of 1 minus x squared times x prime. And this one is negative 1, so it's cosine 1 minus x squared times x prime. So it's just like you copied the formula for the derivative of sine, but you multiply it by negative 1. And for cotangent, it's 1 over 1 plus x squared times x prime. And to find the cotangent, just negate the denominator and the numerator, or the derivative of tangent or inverse tangent. And you'll get the, sorry, this is x squared. You're just copying, but you negate it, times x prime. Okay? And how about here? You will be using the same rule. So the derivative of secant, the inverse of secant is x squared minus 1 times x prime. And of course, you're just going to negate 1 over x squared minus 1 times, sorry, times x prime, or x bar, not x prime, I mean. So look at that, guys. They're just the same, negated, negated, and negated, right? So that's how I memorize the rules or the derivatives of the inverse of trigonometric functions. Okay, so let's work on the f of x. F of x is equal to arctan square root of x cubed. Again, so let's recall y is equal to inverse tan x, y prime is equal to 1 over 1 plus x squared times the derivative of x, right? So you can easily remember the pattern in the given derivatives of the inverse trigonometric functions. So again, guys, arctan is just the same as the inverse of tangent x cubed. Oh, sorry. Wait a second. Okay, so we're now ready. So let me rewrite that. F of x is equal to the inverse tan square root of x cubed. Okay, so we will be using this rule to solve for the derivative of f of x. So that's f of derivative of f of x is equal to tangent, that's 1 over 1 plus the square of the x, which is the square root of x cubed square. All right, times the derivative of the x here, which is the square root of x cubed prime. Okay, so let's simplify. 1 over, oh, sorry. The square root of the square root of x cubed is equal to x cubed times the derivative of this is, okay, let's work on that. The derivative of x raised to 3 halves is equal to 3 halves x 3 halves minus 1 times the derivative of x is equal to 1, correct? So the derivative, oh sorry, derivative of x, something like that. So this is 3 halves x raised to 1 half times 1. So this is equal to 3 halves x. So this is 3 halves x square root of x, or square root of x. So this is equal to what? 3 square root of x over 2 times 1 plus x cubed. There we go. So this is not the derivative of the given function f of x equals arctan x, sorry, square root of x cubed. All right. Okay, I hope you got it correctly. Okay. And how about this? Differentiate y is equal to x times the square of the inverse of tangent x. Oh no, there's a product and there's a power. So what are we going to do with this? So let me just copy the inverse Yeah, 2. Okay, so what do we do with this? The first thing that we need to perform is the product rule because it's product, right? There's a product. It is a product of two factors. So let's review. Y is equal to uv. Both are functions in terms of x. So y prime is equal to uv prime plus v u prime. That's how we do the product rule. So let's do that here. So y prime is equal to, I want to do this first as the derivative, all right? So this becomes tangent or the inverse tangent x squared, okay, times x prime plus x times the derivative of tangent, inverse tangent x squared derivative, okay? So now let's copy this, and the derivative of this is 1. This is equal to 1, all right? So copy the inverse of tangent x squared times 1 plus x. And what's the derivative of this? All right, how do we differentiate this? Since it has a power of 2, so we're going to use power rule. So that's 2 and tangent inverse x raised to 2 minus 1 is 1, right? And of course, we need to differentiate the base. What's the derivative of tangent, inverse tangent x? So that's 1 over 1 plus x squared, right? So that's how we do it. So let's now process this. Tangent, inverse tangent x squared plus, there we go, x. So this becomes 2x tangent, inverse tangent x raised to 1 over 1 plus x squared, right? Okay, so, and then how do we do that? Can we still simplify this? I don't think so. Okay, we cannot simplify this anymore. Or we can factor out tangent. Okay, so let's try that. So let me just copy y prime is equal to inverse time x raised to 2 plus 2x time inverse x over 1 plus x squared. Okay, so I can factor out tangent inverse time x. There's 1 left here plus 2x over 1 plus x squared. But it doesn't really make any difference, right? Okay, so this is now our solution. Okay. All right, so I hope we got the same answer. Okay, try to solve this and let's see if we'll get the same answer for the final answer. Okay, I hope you got. All right, so let's move on to the next problem. Oh, wait a minute. Okay, so we're done with the example number 1, and let's try another example. I think this is the last example. So arc cotangent, so that's, let me just change my color, my pen's color. Okay, here we go. So let me just rewrite the problem. Arc cot can be expressed as the inverse of cotangent 1 plus x over 1 minus x. Okay, and let's just review. Y is equal to arc cot or cot inverse x. So y prime is equal to cotangent, it's negative 1 over x squared of x squared minus 1 and x bar or x prime, okay? So this becomes f prime of x is equal to, we're going to use this formula, that's negative 1 over, our x here is this. Oh, it's quite complex. 1 minus x times the square root of the square 1 plus x over 1 minus x squared minus 1, right? And times the derivative of x, which is the rational expression 1 plus x over all over 1 minus x bar or prime. There we go. So let's try simplifying this out. Oh no. So 1 plus x over 1 minus x, the square root. So this is equal to 1 plus x square minus 1 minus x square, sorry, all over 1 minus x square. All right, I'm trying to simplify the radical. Okay, I hope you can still read this. Later, we're going to rewrite that on the other slide. Okay, so let's differentiate this. This is quotient. So let's use the quotient rule. Log high 1 minus x times 1 plus x prime minus, okay, high the low, 1 plus x times 1 minus x bar all over 1 minus x squared. Here we go. Okay, so let's copy. Oh, that's too long. So f prime of x is equal to, let's copy, negative 1 over, what's that? 1 plus x, 1 minus x, the square root of, this is 1 minus x squared, right? And this is, okay, let me, 1 plus x squared, that's 1, oh, plus 2x plus x squared minus, all right, 1 minus x squared, it's 1 minus 2, sorry, 2x plus x squared. There we go. That's quite long. There we go. Okay. I hope you can still read my penmanship like that. Okay. It's quite hard writing this expression. Okay. And let's simplify this, the quotient rule. So this becomes 1. So 1 minus x. 1 minus x times 1 minus 1 plus x times, wait a minute. Okay, here we go. This one is, the derivative of this is negative 1. So therefore, it's negative 1 times the denominator, 1 minus x squared. Oh, okay. My hand is tired. Okay, so let's simplify. Negative 1. Let me just, okay. Negative 1. There we go. That's 1 plus x over 1 minus x. And we can simplify the denominator. We can have it like this, right? Oh, sorry. Since this is a square, so it should be absolute value. All right, don't forget that. And since we simplified already the denominator, so we have, I can cancel out. So let's do cancellation here. Let's use another color. I can cancel 1. 1 minus 1 is 0. And positive x squared minus x squared is 0. So what remain is 2x plus 2x, that's 4x. Let's use white again. This is 4x. There we go, times, let's simplify this. 1 minus x minus, or positive because of this, 1 plus x over 1 minus x square. So I can cancel out the x's. I can cancel this out. So we have 2, remaining is 2. Okay, so let's rewrite. It's long. Okay. We have 2, so this becomes 2 times -1, that's -2. There we go. And we have 1 plus x over 1 minus, oh, 1 minus, oh no, I think we need to move on to the next slide. Okay, yeah. So this is equal to -1. There we go. Oh, this is supposed to be -2 because of this. So -2, and the denominator is, right, we can simplify this. This is 1 plus x, what? 1 plus x over 1 plus x over 1 minus x times the absolute value of 1 minus x, correct? Yeah, times this times 1 minus x, 1 minus x square times, oh, 2 square root of x. Here we go. Okay, so let's simplify again. I can cancel this out. So this becomes -1. So -1 over, and I can cancel this and this. Okay, I can cancel. Oh, okay. Oh my God, I forgot. Now this is wrong. I was thinking of a cosecant. This is cotangent. See how complicated the expression is? You should be writing the expression properly. Look at that. All right, so let's do again. Wait, let's redo. Oh my God, how many minutes did I waste in that solution? All right. However, if the given problem is cosecant, then we can use that. Okay. All right. So I think this one is just easy. All right. So let me just rephrase. So one, I mean cot 1 plus cot x is y prime is equal to 1 over -1 over this is equal to x squared minus 1 or plus 1, right? Okay, times the x bar or x prime. Okay, the derivative of x. So let's do that here. It's cotangent, not cosecant. Oh my God, what did I do? Okay, 1 minus x. That's why it made my solution so complicated. However, it's possible that the problem would be that one. Instead of cotangent, it's cosecant. So good luck. Okay, but it's still solvable. All right, so now let's use the formula here. So this becomes 1 over, or this is negative 1 plus x over 1 minus x squared plus 1. Okay, that's plus 1 times the derivative of this. So 1 plus x, here we go. 1 minus x prime. All right. Okay, so let's do that here. Let's simplify. -1. So this is 1 plus x squared plus 1 minus x squared times 1 minus x squared. So I already simplified the denominator, okay? And the denominator of the denominator is 1 minus x squared. I already made it, I already took the inverse or the reverse, the reciprocal. Okay, that's the right term. I already took the reciprocal of the denominator That's why I got this expression. So let's differentiate this expression. So this becomes, let's do it directly. Lodi high. So 1 minus x, and the derivative of the numerator is 1 minus high the low, 1 plus x, and the derivative of the denominator is negative 1 all over the 1 minus x squared. There we go. Yeah, this one is easy. Oh my God, what did I do to myself? Okay, so since I already took the reciprocal of the denominator here, so I can cancel this out, all right? And we can simplify the numerator and denominator then. So let me change back the color to white. Okay, that's negative 1. Okay, let's try simplifying. Okay, here, this becomes 1 minus x. Let's use another color instead. 1 minus x minus, oh, this becomes plus because of this, plus 1 plus x. So we can cancel the x's here, and what remains is 2. All right, 2 times negative 1 is negative 2. So that's equals negative 2 over, oh, sorry, the denominator, 1 plus x squared, 1 plus x squared plus 1 minus x squared. Okay, here we go. Oh, sorry. So let's change the color. So let's simplify this one. So negative 2 all over. All right. So, oh, sorry. This is something like this. So let me change. Oh my God. What's happening to my eyes? I can't see the... Okay, here we go. Oh, so what's this? Expand. So 1 plus 2x plus x squared plus expand 1 minus 2x plus x squared, correct? Oh, by the way, let's check if this one is negative 1. Not yet. Okay. So this becomes negative 2 over, I can cancel this out. So 1 plus 1 is 2, and x squared plus x squared is 2x squared. So this is equal to, we can factor out 2, negative 1 over 1 plus x squared. Oh, so this is just the answer for that problem. My goodness. Okay, what did I do? We're doing the most difficult, or yeah, one of the most difficult problems here in this slide. We change it to a more difficult problem, right? Instead of dealing with a simpler one. So our cotangent of 1 plus x all over 1 minus x just equal to negative 1 over 1 minus x squared. This is just like, oh, this is just like the derivative of, yeah, this is just like the derivative of cotangent, right? The inverse cotangent of x. This one. Let's check. Where is it? Cotangent, here we go. This one. Yeah, it's just the inverse of cotangent. Oh my. Okay, so the answer is it's just the derivative of arc cotangent, right? Okay, here we go. So here is our answer. Whew, I hope you got it correctly. Okay, and if you have concerns or problems or questions, then you can just comment your questions or some concerns under this video. All right, and if there are corrections, please let me know right away. Thank you.